For this example, we're going to take a look about how we could find the reference angles of some angles. And it's important when we find the reference angles that when you find your answer that you express them in the manner in which you were given your reference angle. So for example, if you started in degrees, you want to end in degrees. If you started in radians, you want to end in radians. So for example A, we want to find the reference angle of 315 degrees. What this means is we're going to start by sketching a 315 degree angle. Again, in terms of degrees, we have 0 degrees, 90 degrees, 180, 270, and to complete the circle, we're back at 360 degrees. So a 315 degree angle is going to be over here in between 270 and 360. Now the definition of the reference angle is the quickest way for us to take our angle to swing it back around to the x-axis. And if you can see, we have two different directions in which we can swing the angle if we want to get it to the x-axis. We can go this way to get to the x-axis, or we could go this way to get to the x-axis. And hopefully it's clear that the purple way to do it is much quicker than the red way to do it. So we're over here at 315 degrees, and we want to figure out how we can get this 315 degree angle, how many degrees we have to travel to get it back to that 360. Well, to finish it or to close off that circle, we have to travel 360 minus 315 degrees, which is the same thing as saying 45 degrees. So that means if we have an angle of 315 degrees, we have a reference angle of 45 degrees. Okay, let's take a look now at part B. In part B, we have an angle of 5 pi over 3. So we're in terms of radians. We don't see a degree symbol, so that means we're in terms of radians. And anytime I am dealing with radians, I'm going to start by labeling my x and y axes in terms of radians. So 0 radians, pi over 2 radians, pi radians, 3 pi over 2 radians, and 2 pi radians. Okay, so 5 pi over 3 is an improper fraction. I want to rewrite 5 pi over 3 as a mixed number. And 5 pi over 3 is the same thing as saying 1 2/3 pi's. Okay, so let's figure out where 1 2/3 pi's are. So here's 1 full pi to get from the positive x-axis to the negative x-axis. There's 1 full pi, and then we're going 2/3 more of a pi. And 2/3 is in between 1/2. The 2/3 more of a pi is going to take us over here in quadrant 4. Okay, so we're over here in quadrant 4, and I just traveled 1 2/3 of a pi, and I need to figure out how to, or what the quickest way for me to get back to the x-axis is. And again, as we did before, we have two possibilities. We could either travel the purple route, or we could travel the pink route. And again, I hope it's clear that the purple route's faster than the pink route is. So I traveled 1 2/3 of a pi to get from my initial side to my terminal side. I traveled 1 2/3 of a pi, and I want to figure out what this distance is here, from 1 2/3 to 2 pi. Well, hopefully it's clear if I traveled 1 more pi over 3, because 1 2/3 plus 1/3 will get me to 2 wholes. So I want to get to 2 pi, so I have to travel 1 more pi over 3. So our reference angle for this one, in terms of radians, is pi over 3. Let's take a look at 2 more examples. For example C, we have negative 5 pi over 4. And as we did before, because we're dealing with radians, I'm going to label them, but now because it's negative, remember that means our angle is going to move in a clockwise manner. So I have 0, pi over 2, pi, 3 pi over 2, and 2 pi. So negative pi over 4 is an improper fraction. I'm going to write it as a mixed number. That's the same thing as saying negative 1 1/4 pi's. So we're going to start over here. We're going to travel 1 pi in a clockwise direction, and then 1/4 more in a clockwise direction, which takes us over to quadrant 2. Okay, so this right here is 1 1/4 pi's. So we're over here in quadrant 2. Now let's use our purple and our pink again. In order for us to find our reference angle, it's the quickest distance back to the x-axis, so we could either travel to the x-axis like this, or like this, and hopefully it's clear that the purple's shorter. Now, what just happened? I traveled 1 full pi and then a quarter more. Well, the distance from where my angle is back to pi is that quarter of a pi that I just traveled to go from 1 full pi and a quarter more. So we have a reference angle of pi over 4 for this one. Let's take a look at our last example, which is example D. In example D, I am sketching the angle negative 11 pi over 6. Again, notice 2 things. First, notice that I'm dealing with radians, so I'm going to label my axes in terms of radians. And also notice that I have a negative angle too, so that means I'm going to travel in a clockwise manner. So here's 0 radians, here's pi over 2, here's pi, here's 3 pi over 2, and here's 2 pi. Also notice that I have an improper fraction, so we can turn that into a mixed number. Negative 11 over 6 is the same thing as saying negative 1 and 5/6 of a pi. Okay, so I have to travel 1 and 5/6 of a pi, but I have to do that in a clockwise direction. So here's 1 full pi, and 5/6 more is going to take me right over here into quadrant 1. So this is 1 and 5/6. In regards to my reference angle, again, I have 2 directions. I can either travel here, or I can travel here. And again, I hope it's clear that the purple distance is the shorter distance right here. So this is 1 and 5/6 of a pi. This angle over here is 1 and 5/6 of a pi. And this is my reference angle, so to close it, or to finish that circle there, to get to 2 full pi's, well, to get from 1 and 5/6 to 2 full pi's, I have to add a 1/6 of a pi more. So my reference angle here is equal to pi over 6.